In this video, I'm going to go over our 9.4 MyLab examples for the derivative. Okay. Let's find the slope, if it exists, of the line containing the pair of points given here. So we have negative 18, comma, negative 15, and negative 19, comma, negative 17. So remember, I'm going to label these as my x1, y1, x2, y2. And so I know my slope function is y2 minus y1 over x2 minus x1. And it doesn't matter which one you labeled as x1 versus x2, as long as you keep the ordering straight. So let's just fill in the quantities that we know. So my y2 is negative 17 minus, be careful of negatives here. I'm going to group the negative 15 in parentheses just so I remember that I'm subtracting a negative number. And minus 19 minus 18, so I can simplify a little further. Minus 19 plus 18, so I get minus 2 over minus 1, or 2. And so we can confirm this graphically, right? So I'm just going to put a little break in here. So I'm going to start at negative 15 maybe. 15, negative 16, negative 17, negative 18, 16, 17, 18, negative 19. Okay, and so let me plot the points that I was given. So negative 18, comma, negative 15 is about right here, and negative 19, comma, negative 17 is here. So our line would look something like this, that goes through those 2 points, and our slope tells us that we rise 2 units. So here's 1 unit, and here's another, and then we run 1 unit. So slope is rise over run. And so our slope here, or I might just have to put in 2 for this answer. Okay. Now we have the points negative 4, negative 6, and negative 10, and 7. So again, you can label x1, y1, and x2, y2 if it helps. So my slope is y2 minus y1 over x2 minus x1. So let's just plug in the values that we know. Just be careful of those negatives again. So I get 13 over minus 10 plus 4, so negative 13 over 6. So notice how my slope is negative here, so if we graphed it again, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is negative 10. 1, 2, 3, 4, 5, 6, 7. So I have this point, 10, 7. Negative 10, 7. And then let me plot negative 4, 2, 3, 4, 5, 6, negative 6. So now our line looks like this. Notice how it's kind of going downwards from left to right. When our slope was positive, from left to right, our line was going upwards. So that's the difference there. And again, so how we do graphically is we rise, but now because it's negative, we rise in the opposite direction, or downward, 13 units, and then over 6 units. So our slope is negative 13, 6. For this problem, we want to rationalize the denominator. So basically that means that I don't like this radical in the denominator, so I want to get rid of it. And And one way to get rid of it is by multiplying by itself. So square root of 10. But when I do this, if I just do 1 over root 10, I'm changing the original problem. So I have to do root 10 over root 10 because this is basically 1 and I'm not changing it. So if I do 1 times root 10 over 10, or root 10 times root 10, do some simplification. I can combine those roots in the denominator as 10 times 10, or root 100. We know the square root of 100 is 10, so we have root 10 over 10. And that is our answer. Let's try another one. So again, I have this radical in the denominator. I don't really want it there, so I'm going to do the same trick where I'm going to multiply by root 10 in the denominator, or sorry, root 5. And when I do that, I also have to do it in the numerator as well, because it has to be 1. So I get 7 times root 5 over root 5 times root 5. And again, we can combine it like so. And so the square root of 25 is 5. And that's our answer. Okay, for this problem, we are given a graph, and for part A, we have the function as well, but for part A, this is basically what is the slope between my points, slope between -1 and f of -1 and -2 and f of -2, right? If we followed that slope formula we have. So they kind of have it written here on the graph, this section right here. So you can do this algebraically using the function value, but you can also do it graphically, where we notice that we have to go up how many units? 3, right? So I'm going up 3 units, and then I have to go over 1 unit, right? So our slope is rise over run. And so we rose 3 units and we ran 1, so our slope is equal to 3 here. And you can verify that as well by finding this quantity using the function if you want. Okay, so for B, now it's a little different. So I want this f of -2 plus h minus f of -2 over h. So let me do this on the side, f of -2 plus h. So now I have to use my function, so I'm going to plug in -2 plus h wherever I see an x, and simplify that out. So that's 4 minus 4h plus h squared. And so these 4's cancel. Be careful of the negatives. And I get 4h minus h squared. And then remember, that was all in the numerator that we just found. So 4h minus h squared. And then let me find f of -2 real quick. So that's 4 minus -2 squared. And so I get 4 minus 4, or 0. So that actually goes away. And then this is all over h. And then I can factor the numerator a little. I can factor an h out. 4 minus h over h. And now I can cancel these h's. Notice how you couldn't cancel these h's here because there's subtraction. So don't make that mistake. All right, so our answer for B is 4 minus h. And so to find the limit of this, which is really this, we can really just say we want the limit as h goes to 0 of 4 minus h, because we already did the algebra on the previous part. So if we plug in 0 for h, we get 4. So our answer here is 4. All So here we have function 4x squared. We want to know the slope of the secant line. So the secant line is kind of what we've been finding this whole time. It's basically the slope between 2 points, right? So we want to find those points, and we want to find them at x equals 1 and x equals 1 plus h. So we aren't given the y, so we need to find the y's first, because remember our slope is y2 minus y1 over x2 minus x1. So if I wanted to set that up, I would do f of 1 plus h minus f of 1 over 1 plus h minus 1. So if I find f of 1 plus h, I get 4, substituting that 1 plus h, and get 4, 1 plus 2h plus h squared. And then this simplifies to 4 plus 8h plus 4h squared. And then what else do I need? I need f of 1, right? So 4, 1 squared, and that's 4. So let me go up here and add what I just found. 4 plus 8h plus 4h squared minus 4, all over 1 plus h minus 4. So now I'm gonna simplify a little. These 4's cancel and this 1 cancels, so we have 8h plus 4h squared over h. No, it's really tempting to just cross these out, but remember that there's addition here, and we can't do that. So what we can do is we can factor out an h, kind of like how we did in the last problem. So we get over h, and now since it's multiplication between the two, now I can cross them out. So my answer to the first problem is 8 plus 4h. Okay, so for this part, we want to know what the slope of the graph is at this particular point. And this is an instantaneous rate. Instantaneous rate of change. Okay? So to find that, we use this definition, limit as h approaches 0, of f of a, which a is 1 here, because we want to know about 1. So let me just put 1 plus h minus f of 1, f of 1 over h. Okay, so notice that this is what we found in the previous part, right? We used the secant, and we basically found that this simplifies to, no, we're still taking the limit, this simplifies to 8 plus 4h, so we can use that part. And so if we plug in 0, wherever we see an h, we get 8. Okay? And so, let's see, the last part, we want to find the tangent line. So we have the point, let me put it here. So on the graph, we have this function, if you know what that looks like. It's like a parabola, and we want to know at this point 1, we want to know what this tangent line looks like. What's that equation like? And so we know that the slope is 8 from the last problem, right? So we have our m equals 8, and so we can use the equation of line y equals mx plus b, and here we can substitute our 8. And I don't want that b, so how can we get rid of that b? Well, remember that we want to know what this line is at the point 1 comma f of 1. And all we need to do is just find out what my f of 1 is. That's my y value at x equals 1. So how can we do that? Well, luckily we were given the function, so all we need to do is find f of 1 by plugging in 1 for x, and we find f of 1 is equal to 4. So we can plug in the point, let's see, 1 comma 4, and so if we plug in that point, we get 4 equals 8 times 1 plus b. And so if we do a little simplification, we get b is equal to minus 4. And so our equation of our line, if we return to this form, we have y equals m, which is 8x, plus our y-intercept minus 4. All right, so let's do an application problem. So we have 2 hours after the start of a 100-kilometer bike race. A cyclist passes the 68-kilometer mark, and they give you this velocity of 39 kilometers per hour. So we want to know what the average velocity is during the first 2 hours of the race. So to get that, the average velocity will be similar to like a secant line, where we would take y2 minus y1 over x2 minus x1, right? But in this kind of application, our y's are distance traveled, right this way, distance traveled, and this is and our x is the amount of time it took. So amount of time spent. Okay, so after 2 hours we were given, so that's the time, right? We want to know the first 2 hours. The cyclist passed the 68. So they traveled how far? 68 kilometers, right? And so our average velocity is equal to 68 divided by 2, 34. Which is and so 68 divided by 2 is 34. So the average velocity was 34 kilometers per hour. So now if we let f of x be the distance traveled, so from the start of the race, x equals 0 in time x hours, this is what we were talking about before. We want to find the slope of the secant line through the points of that. Well, we basically just found that, right? So at time, or at x equals 0, they're at the starting point. So our y is 0. They haven't traveled any distance. But then for our x2, we check in on them in 2 hours, and we saw that they got to 68 kilometers. So now using our slope formula directly this time, we get 68 minus 0 over 2 minus 0, which will give you 34 again. So 34 kilometers per hour. Now we want the tangent line at the point 2, f of 2. So notice that we're going to have to find out what f of 2 is. But we are given because we don't have the actual function, so we know that our f of 2 is 68. Right? That's our distance traveled after 2 hours. So our tangent line, y equals mx plus b, we know what our m is from the last question. And we get y equals 34x plus b. And so now if I plug in my points, 68 is equal to 34 times 2 plus b, I find that my b is equal to 0. So our equation is simply just y equals 34x. Okay. So now we have an object dropped from a tower. It's about 1,024 feet above the ground. And then we know the object's height is modeled by this function. And for the first part, we want to know how long does it take to hit the ground. So when it hits the ground, right, we have this like little tower thing, and we have the ground. So this object is just falling towards Earth, and once it hits the ground, what is the height of my object? Well, the height will just be 0. So when you want to solve where s of x is equal to 0, what x value gives me that? So let's make this equation and just solve for x. So 16x squared, I'm going to move the 16x to the other side. 16, I'm going to move the 16 to the other side, so that I believe I got 64. Right? And then now I'm going to square root both sides. When I square root, I got to do plus minus 64, which gives me plus minus 8. But remember, our x is in seconds, so does it make sense to have a negative 8 seconds? No, so let's just keep the positive 8 value. And so our answer is 8 seconds. Okay, so now we want to know the object's velocity at the moment of impact. So this is a little different. We're going to use this 4-step process where we eventually want to get to the limit h goes to 0 plus, because this will give us this instantaneous rate of change at this moment when the object hits the ground. So first I'm going to find s of x plus h, which will be my function, but x plus h substituted in. Squared plus 2xh plus h squared. Do some more simplification. And this is, oh, that should be minus. And so this is what I get for the first part. And let's see, we were given s of x, so now we can plug everything in. Limit as h goes to 0 of s of x, which we just found here, so 4 minus 16x squared minus 32x h minus 16h squared. And now we subtract everything out from s of x, 16x squared, all over h. So let's do some simplification. This positive 1024 will cancel with this negative 1024. This negative 16x squared will cancel out with this positive 16x squared. This negative goes with that negative, so that becomes positive. And so we are left with the limit as h goes to 0 of negative 32x h minus 16h squared over h. Don't cancel out this h here, can't do that yet, so let's do some more algebra before we are able to. Minus 32, so I'm going to pull out an h from the numerator. Can cross them out now, and so let me squeeze it over here. The limit as h goes to 0 of negative 32x minus 16h is simply minus 32x, because this term goes to 0. Okay, so that is our answer for this question. All right, so new kind of question. We have this graph, this function, and we want to know what the equation of the tangent line is at this point. So x is equal to 3, and this is my slope, so this is my m. So we have nearly everything we need. We just need one more piece of information. X plus b. We want to know what this b is. So remember how we did this in the previous problem? We plugged in a point in here and solved for b, right? So what is our point? Well, we have 3 comma f of 3. We don't know what that is yet, so we can find that real quick. F of 3 is 1 over 1 plus 3 squared, or 1 over 10. And so let's plug in that point. That gives me the 0.31/10. So 1/10 is equal to minus 3/50 times 3 plus b. So just do some more simplification. And 50 plus 9, I'm going to bring that 9/50 to the other side. And so my b is equal to 14/50, or this is also 7/25. Probably want to simplify it as best you can. So our equation is y equals minus 3/50x plus 7/25. Okay, let's try one more. So we have this new function x squared. Our instantaneous rate of change is -2. That's our slope. And again, at x equals -1. So we have the form -2x plus b. We want to solve for that b. So let me find the point -1, f of -1. And so f of -1, if I plug that in, I get 1. So then our point is -1, 1. Let me plug that in over here. 1 is equal to -2 times -1 plus b. So b is equal to -1. And finally, let me make my equation of my tangent line minus 2x. And my b is this -1. And so this is my tangent line. Okay, so we have a 4-step process to find f prime and then find those values. So I'm given a function f of x equals 2. That's a constant function. So it kind of looks like this, where no matter what you put in it, you'll always get 2 out. So our f prime of x is defined as f of x minus, or f of x plus h minus f of x over h. So we have to find those different pieces. F of x plus h. So remember what I said, anything you put into this function, you're going to get out 2. So f of x plus h is 2, and f of x is 2, so our numerator becomes 2 minus 2 over h, or just simply 0, which kind of works out in our favor. So now our derivative, our f prime of x, now takes on this. So it's similar to the original function where anything you put out in your input, any x value, you're going to get 0 out. So that's why these are all 0. That makes our life easy for this problem. Now let's see another example where this may not be the case. So now we have s prime of x. I'm going to use that form again, x plus h minus s of x over h. And so let's find our x plus s of x plus h. So I'm going to plug in x plus h wherever I see an x and get 2x plus 2h minus 6. And so my s prime of x is equal to 2x plus 2h minus 6 minus our original function, 2x minus 6 over h. So if I do some simplification, 6 minus 2x plus 6 over h, let's see, so 2x minus 2x cancels and the minus 6 plus 6 cancels. So I'm left with 2h over h, or just 2. And so our answer here is 2. So we actually do have the same case where anything you put into s prime of x, you get 2 out because it's a constant function. Notice how there's no x here, because if there was an x here, it would change based on your input, but this function does not. Okay, so for this problem we have a bunch of statements and we want to know which one's true. I believe this is the only question on the quiz, so I don't want to give too many spoilers away, but I will give you a few hints. So the average rate of change from this function from, let's say, any arbitrary function, we want to know if this is true for all functions. So from x equals a to a plus h is less than the instantaneous rate of a plus h over 2, which is just the halfway point. So it's possible that's true, right? So the average rate of change would be this, the slope of this line. So our average is the slope between the secant of the 2 points, and then the instantaneous rate would be this line right here. So it's possible, but let's look at a different function. What if I had the function like that, where my a is here, my a plus h is here, and my a plus h over 2 is here. So again, if I draw my secant line, it would look something like that, where the slope would be some number. But then at this point here, at my halfway point, notice how my tangent line is a little steeper, which would indicate that the instantaneous rate would be greater than the average rate of change. So this function right here would be a counterexample. Okay, so that kind of gives you a hint that this problem is, or the statement's false. So we can throw out A and D, and then I'll leave it up to you to pick between B and C. All right, a different set of questions. So we want to sketch the graph of f and determine where f is non-differentiable. So we got a little piecewise function going on. We have 2x if x is less than 1, and 2 if x is greater than or equal to 1. So basically, if we draw that, it's going to be a line. We're concerned about 1. So it's going to be a line up until some point at 1, and then the 2 indicates that it's going to be a constant function. So based on that, we're left with choices A and C. Now, which one is it? So notice the difference between A and C are whether this point, which I believe is at x equals 1, whether it's filled in or not, right? So to determine that, you have to plug in this, this point x equals 1 into both sides of the graph and see if they're equal. So if I put 1 into the left side of the graph, I get 2, and then because this is a constant function, anything I put into the function, I'll get out 2. So because these two are equal, A is my graph. Okay, so now for part B, or the second part, we want to know when is it non-differentiable. And by definition, our function is non-differentiable if there is a hard corner that meets at a certain point. So notice that there's this hard corner. I'm going along the function, then I have to take a hard right. So that's why this answer is x equals 1. Another way to think about it is that my derivative, or my slope of the left-hand side, doesn't equal the slope of the right-hand side. So this is my constant function, so my function on the right isn't changing, it's constant. So my slope is 0 coming from the right. But if I look at my left piece, my slope is the slope of that line, which is 2, right? Rise 2 over 1, rise 2 over 1, and so on. So notice how these don't match at this x equals 1. And so that's another way to think about this one. Okay, let's do one more. So now we have a graph where we're concerned about the point x equals 0, it seems. Right, and so to the left of 0, I have x squared minus 2, and to the right, I have minus 2. So again, the left-hand side of 0, it's going to act like this parabola shifted down 2 units, like our x squared that we know and love. And to the right of 0, it's going to be this constant -2, right? Anything I put in 1, 100, whatever, you'll get -2 out. So matching those up based on our choices, I get the first 2 options. And so I can throw out the last 2. And again, we have this issue, is my point closed or open at x equals 0? So all you have to do is just plug in x equals 0 for the different pieces. So x squared minus 2, 0 squared minus 2 gives me -2. And anything into this part will give me -2. So that's why this is our option, our answer for here. And then for the last question, we want to know where is it non-differentiable. And so this one, maybe I drew it better, but this one you'll notice that it seems to be a smoother transition between the 2 halves. So that's why it's differentiable for all real numbers. Now, another way to think about it is that, perhaps you will see this later, but if you have a parabola and you want to know the slope here, it's actually this horizontal line, this horizontal tangent line. So our slope is going to be 0. And then for our vertical piece, so here from the left, our slope is equal to 0. And for our vertical piece, horizontal piece, we have a slope of equaling to 0 because it's a constant function. So that's why, again, because these 2 match, that our function is differentiable at this point and every other point. All right. And I believe this is one last question for us. So we want to know whether f is differentiable by considering this limit definition of the derivative and this function. So again, I like to look at graphs, so let's graph it real quick. So first thing to notice, it's like the absolute value of x, but flipped. So it's going to have this kind of shape rather than the right side up. And then this 19 right here just tells us to shift it up 19 units. So this is what we're dealing with. Okay, so this is what the graph looks like. So do you think that our function's differentiable? And it seems to all be concerned about x equals 0. So what do you think? Traveling on this function, I hit this hard corner. So yeah, so it's not differentiable, but this answer is not quite enough to answer this question, because remember, we want to consider the limit definition, not a graphical point of view. So, and also it says f is differentiable, which is not true. So we are really looking at C and D. Right. Okay, so what was the difference? We have, because the left and right hand limits do not exist, or they exist, but they're not equal. So I mean, we can do this. So limit as h goes to 0 of f of 0 plus h minus f of 0. So graphically, we're concerned about this part, right? So is my derivative existing at here? Do I have a derivative at this point? And so my derivative would be positive, because you can think of it as a line almost, if we kind of broke it up into 2 parts. So my left-hand limit would be +1, right? But then if I was coming from the right-hand side, you notice that my limit of this, my derivative, or my slope, you can think of my slope, it would be a -1, right? So because these aren't equal, then that's why it's not differentiable. Remember how we did this one? We looked at to the left and the right. So same concept, where the 2 derivatives from either sides aren't equal. And so that leaves answer D. And so that wraps up 9.4, and I'll catch you in 9.5 next time.